Hello all, in this video I'm going to do the recap of all the 23 videos, and if you go through this video you will understand how you can use in the real-time projects, how you can code in the real-time project, everything. So let's go ahead, and this is our data set. I'm copying the path, so import pandas as pd, df is equal to pd dot read. See, let's import the file here. And why I'm using the low memory? Because I wanted all the memory. So low memory is equal to false means it will disable the low memory and it will allocate all the memory here. Okay. Read low memory, sorry. Okay, we have started with a mistake. That's totally fine. Let's see EDA, exploratory data analysis. Okay, so df dot shape. So 303 rows are there and 14 columns are there, or else you can do length of df as well. And then df dot d types. So all these are the data types, integers and float. This is good. So let's see any null values. Okay, everything is non-null. Also you can do like this one, import numpy as np and df dot replace np dot nan, replace null values with nan values. In place is equal to true is nothing but save this one. Df dot isna dot sum. So there are no null values. If there are null values, it will show the numbers here. I have not covered this topic yet, but I will cover in the next another playlist when I'm talking about the regression. And so we can also see the mean of the values. Okay, the mean, the standard deviation, the variance, and everything here. And also, if you'd like to group by to see group by the target and to see the mean values, you can see here the mean. Okay, if you look at the first, if you want to see the first 5 rows, this is how. If you want to see the last 5 rows, this is how, using df comma df dot tail. And if you want to know whether this is a classification model or not, so df dot target is the label, target dot value counts. So basically this helps you to understand whether how many labels are there. Clearly this is like 1 0, this is a classification model. If you have like 1 0 2, this is a multi classification model. If you have like continuous numbers, then we can call it as like regression model. Okay, now EDA 2, let's do this one. Let's plot the graphs. So this is our data set, and let's plot the graph. For what we can do here, um okay, first let's see this one and this one. We will plot and see like how many people are there versus the disease. So pd dot cross tab df dot this df dot target, this gives something. Okay, even before that, okay, let's import this one, matplotlib inline, import matplotlib.pyplot as plot, import cbound as sns. So pd dot cross tab df dot target of this one. So this column and this column we are doing the analysis, target dot. Okay, so let's plot kind is equal to bar, and let's plot dot show. And this one shows. Okay, now this one, what is this one, right? We should know this one. Let's put some title as well, plot dot title. So this is like gender versus target. On x-axis, x label, let's so this is like gender. On plot dot y label, so this is the count, right? And this one I want it to be here. So this is called legend. Location is equal to 1.020. So this will come here. This is nice, but what is 0 and what is 1 actually? So this is the target, right? So here, if you see here, I'm writing 0. 0 means we can write like no disease. Okay, oops, not here, exactly in front of the log, sorry. Okay, you can see that. So blue represents no disease, and one represents, I mean, blue color represent no disease, and salmon orange color represent disease. For zero represents, okay, here, gender, zero is equal to female, one is equal to male. Okay, so zero is equal to female. So if you look at all the records, the number of females who are having no disease is less, and who are having the disease, they are like high, whereas among the males the number of people who who has no disease are high, and who has disease is less. Okay, this is one of the analysis that we can do by looking at this one. And now let's do finding patterns 2. Let's do one more df.head. Okay, here I'm quite comfortable with this data set. That's the reason I'm going ahead very fast, guys. But when you are doing, you try to understand everything. So here we have age. Here we have maximum heart rate. So I wanted to see the heart rate, maximum age and maximum heart rate of the people when they have disease and when they don't have the disease. So what we can do, we can plot scatter plot df dot maximum heart rate is the lakh. This is the word here. When df dot target is equal when they have disease, df dot age, when df dot target is equal to 1. Let's color, let's say like salmon. Label, I want like to have disease. Okay, okay, you can see this one. Okay, you can see that when by looking at this one, we can assume that when the heart rate is more. Okay, let's also plot this one, plot dot x label. So first one, we have taken the maximum heart rate. So let's play maximum heart rate and plot dot y label. So here it is a count. Plot dot legend log location is equal to 1.020. Okay, this is the disease one. By looking at this one, we can assume that by if the maximum heart rate is more, the disease is like is happening. The people are getting heart disease, and also when they're getting old, they're getting the disease. So here you can say like age, right? So let's also plot the same for when they don't have the disease. Target is equal to 0, age, and the target is equal to 0, color is equal to light blue, so label is equal to no disease. Okay, let's see this one. Let's put a title as well. Why not? Title, max heart rate versus age versus disease, or with function of disease. Okay, so if you see here, now there are people whose age is more than 60, but they don't have any heart disease, and there are people who are elder than 60 years, and they have the heart disease. So this is not a good analysis. And now if you look at over here, when the maximum rate is like high, people are most of the people, they are getting the heart disease. So we can consider that when maximum heart rate is on the heart rate is maximum, people may get the heart disease. Okay, so let's find another plot here, finding patterns 3. So why I'm doing this one, because we should understand what kind of data that we are having. So let's do the age, df dot age dot plot dot histogram. So you can see that most of the people here, they are like in mid of 50s and 60s. Like, they are the ones who are actually getting more heart disease, 50 and 70s. Okay, and then we can also do one more, which is finding patterns for. Let's take a look at data. Let's take this chest pain type. Let's see how many unique values are there. CP dot value counts. Okay, so we can do this one. Plot dot pd dot cross tab df dot target. Okay, this chest pain df dot target dot plot kind is equal to bar. Let's do this one. You can see that okay, so plot dot title just pane type with type HD hard disease, and plot dot x label. What I can do, so such as pane types, plot dot y label. So this is the count. Plot dot show. I don't want this to be here. I wanted this to be here. Plot dot legend location is equal to 1.02. You can keep like best. So wherever it is best, it will update over here. But I don't prefer this to be best. I mean, it will be like float. It will be like dynamic. It wherever it is like fine, it will stay over there. I wanted this to be static, so let it be here. And zero represents something, right? So let's zero represent no disease. So let's write over here. No disease and disease. Okay, this is cool. So this is searching, telling that um, when chest pain type is zero, so most of the people, I mean, when they go for the test and chest pain type is showing as zero, they are like the chances of getting heart disease is like less, because there are like more than 100 people where they don't have heart disease, but only few people they do have heart disease. And this is for example, when chest pain type is equal to 3, so most of the people, the record says that they have the heart disease. So this is all about little analysis. Let's do the correlation analysis. Correlation analysis. So what we can do dot core. So this gives this number, but instead of this one, let's plot something which looks like very nice. So here, mat matplotlib inline import matplotlib dot pyplot as plt import cbon as sns dot set font scale is equal to 1, plot dot figure fig size. I would like to have like 10 comma 8, 10 width and height is 8, and sns dot heat map df dot correlation plot dot show, and here plot dot title correlation analysis. Okay, and let's keep like 10 by 10 here. Okay, this looks cool. And we want to see the values, right? Annotation is equal to true, and okay, they are decimals, and then fmt is equal to dot 1f is fine. Okay, this looks fine, but still I wanted it to be more with 10 or 15. Okay, no, it is increasing the width. Okay, this is fine. And color ce map is equal to yellow, green, blue. C bar is equal to false. I don't want this bar. False. Okay, by looking at this one, actually, you can see like the correlation between two columns. I mean, one represents a strong positive correlationship, minus one represents a negative strong correlationship, and zero represents like a no relationship. For example, 0.3 represents not a good relationship, and something like that. Okay, so by looking at this, you can understand like how is your correlation. Okay, now what we will do, let's start splitting the data. Mm, so this is our data, right? So let's split all of this until x, and this is a y. So this is something that what we have already seen. Df dot drop columns is equal to this one. Let's stop that one. Axis is equal to 1, y is equal to df of target. And let's see the data once. Okay, let's split the data from SQL on training data test data. Import train test split. Some people do like try and test and valid split, but I prefer only two. To be very honest, this is fine. This would be sufficient. Dot c 42 x train x test y train y test is equal to train test split of x comma y comma test size, let it be 0.2 random state. This random state is totally optional, guys. Stratify is equal to y. So it's quite important to check the shape after this one. Okay, so let's develop this by using ML models. So what we will do, instead of one model, let's choose multiple models at a time. So develop ML models. Okay, so let's start with random forest. Okay, let's do a random forest classifier, and then let's do the ROC curve as well, so that we'll cover everything. So from sklearn dot ensemble import random forest classifier. Let's call rf is equal to random forest classifier, n estimators is equal to 100. Let's fit the data x train comma y train. Okay, so this is done. Rf dot score x test y test. Okay, this has of the accuracy is like 83.6. I mean, you can. Okay, let's do this one. From let's do the predictions. Y predict is equal to rf dot predict x test. So these are the y prediction values. Let's compare this with the original actual values. Y test. So let's compare the accuracy score from sklearn dot metrics import accuracy score. So let's also like precision score, recall score, f1 score. So let's do print f accuracy score. Okay, accuracy score of y test y preds multiplied by, okay, let's do this one. F1 score here, okay, 83. So what we can do, multiplied by 100, and I wanted only two decimals, so put like 2f. So 83 is the accuracy score. So let's also print precision score, recall score, f1 score. So okay, let's check here. Okay, so these are all the score, guys. Okay, so our model has performed well. 83 is a good score. So let's also do the confusion matrix. Classification report, let's do. So I'm keeping everything in one go, so that you can watch my video whenever you want to watch, and then you can prepare your own models with the data. But don't worry, I mean, when I was also learning, I thought like, what is this hard data set and what is this California data set, and why people always use this sample one. See, I'm part of the supply chain management team, and I always used to think like how I can use these ML models in the real time. So whether you are in a supply chain team, or a FMCG, or retail, or medical, so you have your own data, and you always would love to see how you can apply ML models in your own data, right? So I will make some videos on how we can apply on the supply chain data as well. So just stay tuned with me. Classification report, y test, y preds. So this gives the recession. I mean, the one thing over here, you always have to ensure that this F1 score, if in case if it is like too much variance, then it's an imbalanced data set, and you have to be very careful. And this is the classification report, guys. So how we validate the accuracy, precision, recall, and everything here. So take a snapshot of this one, print it, and then start referring this one. Or do remember this like anything. Okay, let's also print the let's also like check confusion matrix. Why not? This is important. So let's plot this nicely. Inline import matplot web.pyplot as plt, import cbon as sns, sna.set font scale equal to 1, plot dot figure fix size is equal to 4 by 4, sns dot heat map. I'm going a little fast. So even before that, let's import the confusion matrix from sklearn dot matrix, import confusion matrix. So here confusion matrix of y test. I mean, we're doing the comparison between the actual values and the prediction values, right? Okay, so plot dot show. So plot dot title confusion matrix. It's very much important. It's, I mean, whenever you're plotting the graph, it's not like you plot something. Basically, by looking at the plot, people do understand like what's been happening. So you have to clear like what is this one, what is this axis, and what is this axis. So plot dot x label, so it's the actual values, and plot dot y label predict predicted values. Okay, and so this looks fine. We can see the names here, but I can't see any numbers inside this one. So for that, annotation is equal to true. Okay, and then C map, I would like to, let's go with the blues. Let's remove the C bar. I hate this one. Okay, so there it goes. So now what this is telling that when your actual value is zero, when the person is actually doesn't have a disease, but once your ML model predicted as for one person, it has predicted as they have a heart disease, and for like 19 people, it has predicted accurately. And your model predicted when the person has heart disease, and it has predicted as the person has heart disease, 32 records, 32 persons nicely, but for 9 people, it predicted wrongly. So that's one thing that you can understand from this confusion matrix very quickly. The name says confusion matrix, but this is not at all confusion. This is like a real ideal one to understand. Okay, and now we have developed the model and we did this one, and then let's do this feature importance. Feature importance, rf dot feature importance is, okay, let's see this one. Okay, so let's put this one nicely. Frame data is equal to feature importances index is equal to x dot columns. So in x dot columns are the names. So here let's say feature importances, let's call this one. Okay, so feature importance dot plot kind is equal to bar, label is equal to false. Okay, you can see that how, I mean, which is the most important feature. So not label, legend. So you can see that age is like fine, this gender is like okayish, this chest pain type, it is really contributing, and this FBS, it is not contributing. So whichever is not like not contribute, not well, not that much, so you can ignore that one. So you can again retrain your model with all the ones which are like important ones. So that's how you can use the feature importance. I mean, do watch my another video which I specifically talked about feature importance. And now what else we can do on this one? So we have seen all of this one. Okay, ROC curve. Why not? So from sklearn dot matrix import ROC curve display. This is deprecated. We are not using this one. ROC curve, ROC AUC score. So we have rates. Okay, but let's do y um, rate rates proba. So is equal to rf dot predict proba of x test. So basically these values, it looks like this, right? So 0.82 represents the value. I mean, this is 0, 0.60, 0.970, 0.28 means 1, 0.34 is 1. You can see it here, right? So but I wanted only the positive of this one. So this ROC curve is nothing but so it plots a curve between FPR and TPR, and this is how ROC curve looks like. So if you get a model like a curve like this is a perfect model, and the area under the curve, it should be 100%. If it is like less than 100%, then your accuracy is slightly dipping down. But this is like okay model. Like let's see. And so FP. So let's do like y props positive is equal to. I only wanted this one. Is equal to y Pretz proba. So this selects all, but I wanted one. So let's see the first five values. You can see 0.18, 0.4, 0.3, these values I have got. And now what I can do, FPR, false positive rate, true positive rate threshold is equal to ROC curve of y test actual values and this one. So if you want to see FPR values, you can see here TPR values threshold as well. Okay, so now what we can do here, we have all the data. Let's plot the curve. Define plot ROC curve FPR TPR and plot FPR TPR. Color is equal to, let it be orange, and label is equal to ROC. So plot.show. Let's call this function here, and the arguments FPR TPR. Let's pass this one. Okay, our curve is like slightly better. It is not like perfect straight. Okay, so what is, let's also plot a fancy line like the random model line. So what we can do for that, plot 0 comma 1 color is equal to dark blue. Okay, label is equal to guessing. And also let's do fancy thing, like select line style is equal to this one. Okay, this is fine. So let's put the title, plot.title ROC curve plot.x label. What is the first one? FPR, false positive rate. Plot.y label, true positive rate, and there it comes. So this is our answer. Now let's see what is the value under the curve. So ROC AUC score of y test, y props positive. So here it is like 91.6. This is not that bad, to be very high, to be very honest guys. This is like okay-ish. So we can go ahead and with this model. Okay, cool. And now hyperparameter. Now let's run multiple functions, multiple models. So we have so far we have seen one model. So let's see how we can train multiple um, models at a time, run multiple models at a time. And just give me 1 second. Okay, let's take three models and let's run all of them in one go, and let's see which one works much better. From sklearn.neighbors neighbors, import k neighbors classifier from sklearn dot ensemble, import random forest classifier from sklearn dot linear model, import logistic regression. So now let's say models is equal to knn, k neighbors classifier. Let's say RF stands for random forest classifier, and LR stands for logistic regression, right? So for name comma model in models dot items, let's iterate this one. Okay, let's put this in a function so we can let it be fine. um, model dot fit x train y train. Okay, model dot score x test comma y test. So let's put this in a function, define fit and evaluate. Okay, so put all this one. So like one more variable, model scores is equal to this one. So model scores of name is equal to this one. I wanted to return this one, return model scores. Okay, and then let's run this one, fit and evaluate. So what we have to pass here? So here it has to be models x train x test y train y test. So let's copy the same until here. Let's paste it here. Okay, so it has given like KNN as like 15% of accuracy, random forest 80%, and logistic is 80. So this is how you can compare multiple accuracies, and whichever is the best, you can go ahead with that. And that's it, guys. Thank you for watching this video. That's all about this one. And if in case, for if you have any questions, please do reach out to through my email address. I have pinned my email address in the comments. Thank you for watching this video.